The research enhances GitHub Actions visibility by automatically categorizing them using transformers and few-shot learning. The authors propose Gavel, which leverages README.MD files for each action to assign suitable categories. They compare their approach with a state-of-the-art baseline, demonstrating its effectiveness in assigning categories to GitHub Actions. This innovation aims to make actions more visible and accessible to developers, bridging the gap in the GitHub ecosystem where many actions are not categorized. GitHub Actions are crucial for automating repetitive tasks in software development, but their visibility is hindered by the lack of proper categorization. To address this, the authors propose Gavel, a novel approach that leverages sentence transformers to categorize GitHub Actions accurately. The performance of Gavel is evaluated on a curated dataset collected from GitHub, and the results are compared to a state-of-the-art baseline. The significance of categorization is demonstrated through a motivating example, which illustrates how actions without categories are less visible and hinder collaborative development. The authors also provide a comprehensive review of related studies, including Prana et al.'s qualitative study, GHTREC, Azadi et al.'s fine-tuned BERT model, and hybrid rec, which have contributed to the understanding of categorization algorithms for GitHub Actions. Gavel's approach is distinct in its ability to assign categories to GitHub Actions using sentence transformers. This is achieved by fine-tuning pre-trained language models on a large dataset of GitHub Actions, enabling the model to capture nuanced patterns and relationships between actions and categories. The published tool and dataset will facilitate future research in this area, enabling the development of more accurate and efficient categorization algorithms. The evaluation results show that Gavel outperforms the state-of-the-art baseline, demonstrating its effectiveness in categorizing GitHub Actions. The authors also discuss the limitations of their approach and identify areas for future work, including the need for more diverse and extensive datasets to further improve categorization accuracy. The research paper, Automatic Categorization of GitHub Actions with Transformers and Few-Shot Learning, tackles the challenge of categorizing GitHub Actions due to insufficient training data and tools. It introduces Gavel, a novel tool that leverages transformers and few-shot learning to categorize GitHub Actions based on their README.MD files. The proposed architecture consists of 4 key modules: extraction, tokenization, classification, and few-shot learning. In the extraction and tokenization phases, a Python library for MD files, Marco, is utilized to parse data from README.MD files and encode it using a tokenizer. The classification phase adopts the one versus all multi-label classification paradigm, allowing for the categorization of actions into multiple labels. The few-shot learning approach is employed to train the model with a minimal amount of data, addressing the issue of data scarcity in this domain. Gavel's significance lies in its ability to address current limitations in GitHub action categorization, particularly in handling diverse components of README.MD files and mitigating the lack of labeled data. By leveraging transformers and few-shot learning, Gavel offers a promising solution for the efficient categorization of GitHub Actions, enhancing the overall usability and organization of these resources within the developer community. The evaluation methodology section of the paper outlines the materials and methods used to evaluate Gavel and compare it with the state-of-the-art baseline, CNBN. The research questions focus on categorizing GitHub Actions, determining the best prediction accuracy configuration, and comparing Gavel's performance to CNBN. The metrics and datasets used include true positives, false negatives, precision, recall, and F1 score. A dataset was created by combining data from 2 sources, resulting in a single dataset containing 1,213 unique actions across 30 categories. Gavel's evaluation configurations are detailed, including the use of different types of README.MD data as input. The section concludes by describing the experimental configurations and their sample sizes. The paper explores the automatic categorization of GitHub Actions using transformers and few-shot learning. It presents a classification report for various categories, including AI-assisted, API management, backup utilities, and more. The authors detail their research methodology, involving data collection from GitHub Actions and the application of machine learning models for classification. They emphasize the need for a suitable tool to classify actions into categories and share experimental results using different configurations. The findings indicate that the usage of GitHub Actions is still in its infancy, highlighting the need for an automated technique to classify actions into categories. The evaluation of Gavel's performance compared to CNBN on GitHub Action categorization is presented. Gavel outperforms CNBN in terms of precision, recall, and F1 score, with precision values exceeding 0.70. CNBN, on the other hand, is more timing efficient, requiring less than 1 second for training and testing, whereas Gavel requires several hundreds of seconds. The study highlights the need for tokenizers tailored to each type of input data to further improve Gavel's performance. It also suggests exploring more lightweight techniques to maintain a trade-off between accuracy and effectiveness. Gavel, a practical approach to categorizing GitHub Actions. The absence of a standardized categorization system for GitHub Actions has hindered their effective utilization in software development. To address this limitation, this paper presents Gavel, a novel approach to categorizing GitHub Actions. A comprehensive literature review of premier software engineering venues revealed that Gavel is the first tool to tackle this issue. An empirical evaluation was conducted on a dataset collected from GitHub Marketplace, demonstrating Gavel's capability to provide suitable categories for actions. Notably, Gavel outperformed a state-of-the-art benchmark, showcasing its effectiveness. The authors plan to extend Gavel by integrating lightweight classification models, striking a balance between effectiveness and efficiency. The development of Gavel was supported in part by the EMELIOT research project, funded by the Italian Ministry of University and Research under the PRINT 2020 program grant, and the European Union Next Generation EU through the Italian Ministry of University and Research, projects PRINT 2022 PNRR. Fringe. Context-Aware Fairness Engineering in Complex Software Systems, grant. The proposed Gavel approach has significant implications for software development, enabling the efficient categorization and utilization of GitHub Actions. This research contributes to the advancement of software engineering, providing a foundation for future work in this area.